Good morning, everyone. We will be starting shortly. Let us take a moment to allow all our participants to join us. Your patience is greatly appreciated. Thank you, everyone, for waiting.
Somdatta, please start the session. Somdatta,
Y- Yes, sir.
please start the session. Give
Sure, sir.
introduction of our speaker for this session.
Sure, sir. Just a minute. Good morning, ladies and gentlemen, esteemed guests, faculty members, and participants. My name is Shomdatta Mukherjee. I'm your host today. Welcome to the second day of RTCI, Recent Trends in Computing and Informatics, organized by the Department of Information Technology. So, Kunal Kumar, can you please mute yourself? Thank you. So, over the next few hours, we will have the privilege of hearing from some of the brightest minds in the field, esteemed guest speakers who will share their insights and experiences on latest advances in computing and informatics. Yesterday was a testament to the power of innovation and collaboration in the field of computing and informatics. Today promises to be equally exciting as we delve deeper into cutting edge technologies, trends, and insights. Without further ado, it's my pleasure to introduce our first speaker of the day, Mr. Shudipto Bhomik, a seasoned consultant and solution architect at Tata Consultancy Services Limited, engaged with the current organization for more than 19 years, with around 3 years prior experience with Citicorp, another IT service provider organization. Mr. Bhomik got certified as AWS Solution Architect to build a foundation for formulating data service architectures, adopting the cloud application design principles, monitoring and maintaining the platforms. He worked on data centric programs ranging from large scale data integrations, designing data warehousing solutions, database migrations, and platform upgrades, building IT solutions for leading global organizations across varied industry domains like insurance, banking, life science, and retail. He has experienced in delivering few of the critical data service based solutions for global customers, managing teams across varied locations, as well as managing customer facing roles on one side. His expertise in data services on the cloud, coupled with his extensive background in solution architecture, makes him a true authority in the field. Let us give a warm virtual welcome to Mr. Shudipto Bhomik. Over to you, Mr. Bhomik. Thank you.
Yeah, thank you, Shamdatta, for just giving that presentation and introduction for me. I hope I'm audible, right, to
Yes,
everyone?
you're audible, sir.
Okay,
Thank
thank
you.
you for that. Very good morning to everyone. It's really a pleasure for me to have something of this sort. To be very honest, I am not that familiar with this kind of presentation or webinar. I had been working in this organization for quite long. I had been in pre-sales presentation to customers for various purposes. But this kind of audience, this kind of presentation, I'm not that familiar. So just before I start with my experience and my journey on this particular topic, I would just like to just have some introduction. Basically, that I would like to have this kind of session as a more kind of informal and interactive one. I see a lot of students have joined over here, so it's really a very good feeling that like so many students have joined. I see myself back to many years from now, when I was in your position. Basically, I was just out of the college, just joined, like I was an aspiring student, and I was fortunate enough to get a good opportunity in one of the IT organizations, and from there the journey started. So I can see myself in your position right now. It's really a good feeling. So having considered that, I would definitely, you all should agree with me that over the time, like maybe if I take the period of 15, 20 years, the place and the way that we started off in the IT career or the organizations, there had been some radical changes over the years. Like in last 5 years, it was a havoc change that happened in the IT field. So you all should be gradually knowing like what are the emerging trends and what are the changes that are happening in this industry. So where we started off, basically, it was more of a kind of traditional architecture, like in terms of the data, how we used to model the data, how we used to design the architecture, about the server-based architecture and that kind of thing. But now, as you have all been kind of, you are not only kind of studying that particular concept of the cloud computing, but in one hand, you are actually a consumer of that cloud environment or the cloud services. To be very honest, like you are on a day-to-day basis, like you are actually using some of the services of the cloud, maybe knowingly or maybe unknowingly, but eventually you're using some sort of the cloud services. I'll come to the details about what are the kind of emerging trends in the cloud, why the organizations and the enterprises are moving into the cloud platforms, what are the key benefits. But as a common man, as an individual, I would request you, you also should take that interest in just learning that what are the different types of applications that you're using, maybe within your mobile phone or in your laptop or any other kind of platforms, that you definitely are using a particular cloud services in one way or the other. So today, in today's world, I would say that it is kind of indispensable. Obviously, it is not mandatory that like everything should be kind of transformed to the cloud platforms. There are certain rationale, there are certain understanding, some decisions need to be taken. But overall, I can say that in today's generation, this transformation is one of the most remarkable transformation that has happened in the IT field. Okay, so definitely there had been some benefits. So organizations, enterprises, and even as an individual, we found certain benefits in this cloud platform. So if I take the example of the services that we're using in the phone, for example, the Amazon services or maybe the online courses and everything. So in the backend or in the background, maybe like some of you, all of us are not taking that interest in learning like how the services are integrated, how the thing that you're seeing in the mobile screen, or you're just doing some operations in the screen. So that is getting translated into some particular, I mean, some kind of transaction. Okay. So how is the transaction getting executed at the backend? What are the platforms involved? What are the typical services? Okay, the data exchanges that are happening across the interfaces that maybe through your mobile and from some backend database or services. So those all things are entirely kind of getting controlled through the cloud. Okay, so I would not go deep into some theoretical concepts because that is not the objective of this session, I believe. Those all things you must be already studying in your curriculum, like what is the cloud, what are the key advantages of cloud, so what are the typical services that you are offered in the cloud. But what I will try to share is basically a kind of a real-time experience, like the way that we are working as in a big organization, the way we are serving the different enterprises in their kind of fulfilling their requirements. Okay, how they're adopting the cloud, what are the rationale they are having behind adopting the transforming to the cloud, and what are the challenges that we are facing. Okay, what are the concerns of the customers. So I would like to give you some kind of a picture on that, rather not going deeply technical into the cloud services. This is not an academic session, obviously. It's more of a kind of industry exposure, because I was in your position a few years back. So I didn't have any kind of idea about how an IT organization looks like, how does it operate, what are the services that it provides, who are the customers, what kind of services is designed. Okay, what are the valuations for that, what are the transformations. I didn't have any kind of idea. So I started off with mostly on the data background. So it's on the data services. So as I said, like when we started off, it was more of a kind of on-premise applications. So we had, typically speaking, any applications that we had working was it was having a backend, it was having a front end. Okay, there had been data exchanges between the front end and the back end, and the integrations used to happen in typical manner in a three-tier architecture or two-tier architecture. So gradually, like when I was involved into the data services, so I started out with like, then I moved on to the data warehousing part, which is one of, you must have heard about data warehousing, the business intelligence part. So it's more toward like how we model the data to cater to the business needs. So those all kind of background I was having in executing different kind of projects over here for different type of customers. So in that way, I gained varied types of experience. But over the last, I think around like 5 6 years, there had been a remarkable transformation where all the enterprises, most of the enterprises, I would say, whatever applications that they're having, okay, so they are trying to kind of either re-platform that to the cloud. They're looking for opportunities and options about how to migrate their applications and their entire data ecosystem into the cloud platform. So in that way, we also were fortunate enough to get that opportunity of working with some of the big enterprises, okay, in different types of programs. So in that way, we came to know about in today's industry why the enterprises are actually moving on to the cloud. What are the key benefits? Okay, so in that way, I would try to share something about like what are the learnings that we had, because I am not an expert in this field, to be very honest. So whatever the experience that we gathered, I mean, through the execution of the different programs, what are the challenges that we have faced? So I will just try to portray in that. Stop me at any point of time if you have any kind of questions or queries. Okay, I am absolutely welcome. And also, I will have an interactive session after the presentation is over. So I just like to take the help of a small presentation that I just built, just to be in a more context that the topic that I'll be discussing right now, like what is cloud computing and how are the enterprises adopting to the cloud in today's world. So to facilitate that, I just will take the help of a small presentation. Maybe I will share my screen. Just let me know once the screen is visible. Yeah, is my screen visible?
Yes, sir, the screen is visible. Thank
Are
you.
you also able to see the presentation, right?
Yes, sir.
Okay. So as I said, like this is just how the enterprises are adopting to the cloud platforms. I would not specifically like stick into any particular cloud service like AWS or Azure or GCP, but in general, like what are the principles that are followed? What are the rationales? Okay. So just to start with, like this is, do not consider anything as more of a theoretical kind of thing. It is purely like you will find this kind of descriptions in the textbooks or in the journals. But to be very honest, like why cloud? If we say like what are the main rationales behind transforming to cloud? If you look at this point, so we have actually encountered these kind of scenarios, this kind of business cases, why the enterprises are today in today's world are gradually trying to move into the cloud. Okay. So the very first example that you see is the legacy applications. So when we say the legacy, it's the old applications in traditional architecture where we have a client server kind of model. So we used to have like the local installations, there was server, the database was residing in the backend, the exchanges were happening via different methods. Okay. So often we have seen that in the enterprises, the applications that had been residing legacy in a legacy platform, those are outdated. When we say outdated, it's not that it is not working, it is not operational, and it is failing to fulfill the customer demands, but outdated in the sense like it is less adaptable to the modern technologies. The flexibility that is being offered as part of that applications and the platforms, that is getting outdated. Okay, so it has a limited type of licensing. Like obviously we understand like if you buy any product, for example, any database, any RDBMS from any renowned service providers like Oracle or Teradata, or even for the front end side, so they have a licensing kind of method. So obviously that license are getting expired in some time or the other. That was one of the main limitations. And overall, if I say the application, so those applications are also getting kind of obsolete. So it had very limited flexibility. It had kind of like I mean, it is not scalable enough. Okay. And often like we have seen that from maintenance perspective also, it's getting very difficult that the customers are facing too many challenges in maintaining those kind of applications in the traditional architecture. Okay, from growth perspective also, they are kind of lagging behind in maintaining those kind of legacy applications. But there are some advantages of maintaining the traditional architecture. I'll come to that later. In some cases, in some scenarios, obviously, we have to, or some of the enterprises have been stuck to those kind of traditional architecture. There are certain scenarios also. Okay, so modern technologies, if I say like it is less kind of adaptive to the modern technology. If you need to do any kind of integration of a new kind of data source, for example, if I take the example of a streaming data. So nowadays, like the data sources are varied kind of nature. In old world, it used to be some traditional kind of file-based data integration or some kind of relational data that was integrated into the platforms. Nowadays, like a lot of analytics and those kind of things are going on. So for that, we need to have the streaming kind of data. For example, the data that you are browsing in your mobile phone. Let's say you are using Facebook, you're using WhatsApp, you're using Amazon services, you are using some other services. Okay, so all those data is getting collected, and there are enterprises which are using that kind of streaming data. Okay, whatever the queries that you are actually pushing into the application on a random basis, so those kind of streaming data, which is more sort of an unstructured data, so that kind of data is also kind of pushing into the applications, and customers having need to analyze the data and come out with certain kind of use cases. So those kind of integration get very difficult in the traditional architecture or in the old base, like if you say the three-tier architecture or the client serverless architecture. It is less adaptive, like it cannot ingest or it cannot integrate such kind of unstructured data. That is one of the use cases. One another interesting example is the capex cost. The capex is basically capital expenditure. So at one time in the traditional world, when the customers were actually investing on a hardware and the licensing of a typical product that they're having in the architecture, so at one time it is basically like they're having a huge cost of maintaining that application or the hardware. Okay, you are very aware that there are licensing costs also. So maintaining of those licensing costs, it gets a very big overhead for them, and they have to do the renewal of the licenses. For example, if they had bought Teradata or Oracle as an enterprise data services, so like the licensing cost is also very huge. The other challenge, which is actually not known to a lot of the enterprises and customers, is that it is in many cases we have seen, and even the customers have experienced, that the usage of the application, the hardware, or even the services are not optimal in nature. When we say optimal, like the planning doesn't go well. So let's say we have procured, let's say, 1,000 GBs of kind of database space. Okay, so in the actual application design, there have been a lot of false design or faulty design for which we are unable to use that entire 1,000 GB of space. So a lot of things are actually getting unused, but we have to, the customer is having to pay for that. So even though we don't use that, okay, even though we don't use a service, even though we don't use a particular database space, but still the customer is having to pay for that. That was one of the biggest rationale about moving to the cloud, because it is the caption goes with the cloud that you pay as you go. What does it mean? Basically, whatever extent you use, you pay only for that. It's the most kind of a postpaid and prepaid connections on a mobile phone. So in the postpaid, you know that you will be paying a fixed cost. Okay. Now, even though we don't use that, okay, you have to pay that. In the prepaid, you pay as much you use. So that is the basic difference about, and the main rationale why customers were concerned about the capex cost getting increased in terms of hardware and licensing. Then obviously, which is very obvious, the data center leases, the software renewals, it all comes together. So the expiry of those kind of services were another big concern. Now, if I take the example of, like, there's a new demand coming, let's say I have to upscale my platform to accommodate a huge kind of data increase. Okay, I have integrated a new system into the application. Okay, so for that there is a huge need to increase the space. Okay, like space of service, the computing servers, or even the database spaces. So everything need to be increased. Now imagine in the legacy world, like in the traditional architecture. Now you have to plan like how much you need to increase in terms of like space or services. Okay, so you have to discuss that with the service providers. You have to procure that, and it's a long time process. It goes via approval and all those things. But in the cloud, basically, it is as simple as you can procure a resource in a matter of few minutes only. If you have an active subscription, so just a matter of few minutes that you procure a new service, you procure a new database. Okay, you can even enhance your computing resources. So it's always not that you have to procure it newly. It's obviously a scalable application, so it is kind of it keeps on getting increased For example, if it sees that you can keep those options that if the computation requires more kind of clusters or more kind of servers, so automatically the cloud provides you that. It doesn't necessarily needs a discussion. It doesn't need a negotiation, a cost bargaining kind of thing. So you know the model, you know the cost model. As and when the as an application gets kind of heavier, the cloud automatically adapts you to provide you that kind of computational services or in the database or the storage services. Okay. Now, data accessibility, governance, security, often unstructured. Now, data accessibility was also a very kind of complex mechanism in the traditional architecture. So you had to very well plan about what are the who are the users that are going to access the data. Okay, how you are going to control the security, the access. There are very limited options about giving the access to the data to the end users. Okay, maybe through some reports or maybe through some other guidelines, but it is often difficult to get the underlying data, the core data that you are actually constructing. That access cannot be given to the end users, and it's very complex in how you give the access to that. Okay, but in the cloud world, basically you can actually expose different layers of the data to the users based on their user requirement. You can very well control the security. Now, if I talk of governance, so governance is basically the regulations in an organization or enterprise that how they want to kind of govern the access of the data. It's not that you can expose any data to anyone. Okay, so there are certain limitations, there are certain guidelines. So that governance also in the traditional architecture, it gets difficult because there are a lot of small ghost applications. There are a lot of users, type of users, okay, who are actually using a particular set of data. So uh, there is no central kind of governance authority or like who actually controls the access of the data. That is a big challenge. So in the cloud world, there are options about how you can govern the data, how you can put the access control individually through individual data sets or individual services. You can control the access of that particular object. Security is also kind of often unstructured. So in the cloud world also, we will come to the discussion about how we can structure the security of the data. Sorry. Now, one basic thing is that the applications are anti-agile. So agile term you must be aware of. Like in today's world, everything like every of the program execution, like it is gone of those days where we used to have a big program. We used to have the requirements captured, then the design assessment, then the build testing, and then finally delivered. So even a big program is getting converted and executed or delivered in an agile manner. So we have small sprint models. Okay, so in the traditional applications, it is very much less adaptive to the agile methodology. Okay, so it's a big application, big program. So you have to design everything from scratch in a new manner. Having said that, again, I just reiterate the fact that it is not that all the applications entirely what is existing in today's world for the enterprises are absolutely eligible to be moved to the cloud or transformed to the cloud. There are certain use cases, there are certain applications which are actually more better suited in the traditional legacy on-premise architecture. Okay, so I'll come to that later. Now, those applications were not horizontally scalable. Scalable, if I say, like, as I mentioned, like if you need to increase your computational clusters, if you need to increase your database space, those were not easily possible. Like you have to do a very long process for that. And obviously, it is less flexible. Application outages. Outages is basically the downtimes. So often we have seen that for the maintenance purpose of the traditional the services, for example, any database or any kind of computational clusters and all those things. So we had to, I mean, totally down the application. We have to put off the application and then do the maintenance. So those gone are those days where you can actually afford to that. So the expectation for all the applications enterprises are that any application that you're running, it should be up 24 into 7. There cannot be any outage. So the cloud services actually are very much kind of competent in providing that kind of a flexibility and that kind of availability of the data. So the tagline that the cloud service provides is basically it's available and it's scalable. Now, availability is 99%. Availability is ensured for most of the cloud service providers. So it is completely a kind of headache of the cloud service providers in keeping the environment ready and up and running. Okay, so it is not a matter of kind of enterprise to plan that. Okay, what measures do I need to take to make the applications in a running state? It is entirely kind of managed by the cloud service provider. Okay, the change management process. So for any kind of change management, like for any kind of change request or enhancements, it is a long process that used to take in the previous world. So in the cloud, there I will come to the different types of services like DevOps services, okay, DataOps services. So through that, actually, the even in an agile world, the change management is also has become very easy for that. Now, I already discussed to some extent all those points over here, like what are the benefits that enterprise actually looks behind this transformation. Obviously, the cost effectiveness. Now, this is a very kind of dicey phenomenon or aspect that is currently under evaluation. So, when a customer indulges into a cloud transformation, he is not very sure about whether he is going to save any cost as compared to what they are having in the current state in the traditional architecture. So cost effectiveness in one way, obviously a cloud service, as I mentioned, like one of the use cases where they can save the cost is that uh, they will only pay for what they use. That is one of the critical thing, which uh, which is predominantly kind of influencing the customers in taking the decision for cloud migration. Okay. Then business continuity and disaster recovery. As I mentioned, the onus of maintaining the environment, the onus of maintaining the services is entirely on the cloud service providers. So basically, like the customers can actually involve into multiple other kind of activities, multiple other decisions, planning, and those kind of things, rather than taking the headache of maintaining that application and the environment. So there is no outage, there is no kind of disorder, there is no kind of break in the services. So everything goes on smooth. That is what is ensured by the cloud. Enhanced security. So there are multiple security aspects of the cloud, like how the data and the services are actually secured in the cloud. That is one of the biggest concern also for the customers. That what about my security, basically? So in today's world, like once, like in our world also, if I take the individual case also, we are very kind of skeptical in sharing any our personal information over the internet. Okay, as soon as you put any kind of personal information in the internet, there is a suspicion that that information is going to be hacked, that information may be leaked. Okay, so there is every possibility that such thing happens, because a lot of applications are vulnerable in terms of security architecture. But the cloud, over the time, obviously over the time, they had enhanced the security of the data that the customers are actually putting into the cloud. Okay, even we are also kind of relying in some cases where we are putting our files, our sensitive files or big files into, let's say, Microsoft Drive or Google Drive. So everything is basically a cloud. We are using those kind of platforms in our own individual way also. So enterprises definitely have certain reservations about putting sensitive data, putting kind of secret data into the cloud. There are use cases. I'll come to that. Yeah, moving on to like collaboration and productivity. Yeah, this is another kind of interesting thing. Like you can actually in a cloud, if you design the entire ecosystem in a cloud, you can have a more kind of collaborative kind of work model. Like the different applications, you can do some data exchanges between the applications. You can give the access of the data to multiple users. Okay, you can actually bind your entire organization into one kind of thread by securing the data, and you can give access control to particular data services, so that that entire governance of the data gets a very kind of clearly defined. Okay, productivity is also increased, like as I mentioned, like you do not have to bother about designing the services. Like there are ready to use services, like if you use cloud as a software as a service or platform as a service. So you have an already integrated platform where you can simply you not do any coding also. Okay, so those kind of things are also available. So in that way, designing or building an application, you can increase your productivity also. Okay. The most catchy factor, the criteria that cloud has provided is the scalability, the flexibility, and the availability. As I mentioned, I'm not repeating the same. It's already proven that it is the most flexible and the scalable and the available platform that any kind of organization can use. Adoption to the DevOps. Okay, DevOps is something, it is kind of an integrated platform, like an operation, a process basically, where the development and the implementation, deployment, everything goes hand in hand. Okay, so it's not a very long process. You can define your workflows and everything. So, sorry, you do your development and you deploy your kind of changes into the production environment. So those kind of things go very easily. Okay. Now, this is just a kind of a brief background, like it is not an easy decision for an enterprise to move to a cloud. Okay, so like as they are not having that understanding, even in our side also we are not having that extensive understanding about uh, whether really there is any benefit while moving to the cloud. Okay, so the factors, there are different factors which influence organizations about moving to the cloud. But overall, what we have seen is that for any big organization to take the decision about moving to the cloud, like putting their entire architecture and the data ecosystem into the cloud, that is a very tough decision for them. Okay, because it is kind of an unknown ground. Okay, what kind of cost implications will come up? Okay, if they have taken the decision to move to a cloud, okay, so the executive backing is a very crucial thing. Like for the top leadership of the organization, then there should be a sufficient support about whether the organization should actually move to the cloud. If there is a kind of conflict in that, often we have seen that like it actually causes more of a damage than a success. Okay, so that collaboration between the leadership, the executive, and the actual implementers, that holds the success behind any kind of cloud transformations. Now, it is obviously a very difficult task. Like there is a host of area of applications and service awaiting that kind of cloud transition. Okay, so there is no single solution also, like how to migrate a particular application. I will come to what are the different approaches, the strategies that can be followed in migrating the application, but there is no single way. It depends on organization to organization. It depends on platform to platform how the migration can happen. Now, it is also an evolving journey. It's not that on the day one or even the first migration that you do on the cloud, like you are actually having a success as an at an enterprise level. So it is a journey basically. So it is like over the time, like you can start off with a piloting application. You do you plan your strategy for the migration to the cloud. You do the migration, then over the time you gain the experience about what are the challenges that you have faced. Okay, what are the mitigations? Okay, and in the next plan or the next phase, okay, what different model or the different method that you will apply for migrating the remaining of your data ecosystems into the cloud. Okay, so these benefits keep on getting kind of it gets apparent basically. Okay, and over the time you understand that how to deal with the new normal. That is another challenge, like to educate the users, to educate the customers, the end users of the data, that you are actually accessing the data from a different platform, from cloud. Overall, there is no difference, but this is a huge challenge for the enterprises to educate the end users or educate their IT users also using the new services which they're not familiar with. There is obviously some differences in what, like for example, if I am using an Oracle relational system, okay, in the previous architecture, and now I have moved to the cloud. Let's say I moved to Amazon RDS. Now it is a different type of database. Your UI will, the user interface will change. Your way of accessing the data will change. Okay, the connections will change. So these all things need to be made familiar with the users of the organization. Okay? That is a big challenge. Now, this is a very kind of interesting approach. Okay, what I would say, like before any organization indulges into a cloud transformation journey, some of the key steps that they should follow. This is not an ideal thing. Okay, it is more of a kind of a I would say a kind of a high level guideline. Okay, now obviously an organization did not necessarily follow each and every of the step over here, but from our experience, what we have seen, this is an optimal way in which you can actually begin your transformation journey to the cloud. So overall, I can differentiate into four different phases: the discovery, then we strategize, then we implement, and then we expand and modernize. It is obviously a kind of, you give birth to a particular kind of object, okay, a journey. Now you keep on learning during that journey, okay, and then you implement your experience over the journey and you modernize your platform. So to start with, you need to first of all have a plan, like what is the timeline that you're looking for beginning of a particular journey to the cloud. So the very first thing that an enterprise should be doing, and what enterprises actually does, is that they have a discovery phase where they kind of evaluate and discover the core cloud use cases in the ecosystem. Like they have different kind of use cases, there are different type of applications. It's not necessary that they will need to migrate all of the applications in one shot into the cloud. that is absolutely not advisable also, because that can be a tremendous failure. Okay, if you don't have the competency, if you don't evaluate whether that is the best fit for the cloud, then it's a total failure. So from, let's say they have 100 applications. From 100 applications, they have to identify that, okay, 10 of my applications are best suited for the cloud. Even among 10, what is advised is that you pick up any two topmost priority, because this is something you are going to try. Okay, there can be failures, there can be risks also. Okay, so better not to have a big bang approach, rather than go in phases, go in small steps. Okay, then decide that what type of cloud suits your requirement. When we say what type, basically we have private cloud, we have public cloud primarily. Okay, now public cloud is something what we have like the Azure, AWS, or Google services. So these clouds are public cloud. When we say, it's totally based on internet, and the services you have to access by the internet, and you are actually exposing your data to that entire public cloud. So there can be reservations also. Now, in case if you have sensitive data, if you have private data, you have to go for private cloud, which is more expensive. Now, every other service providers provide that private cloud options also. But the thing is that you have to decide about what type of cloud you want to suit. Then the service provider also. For example, like if you want to choose Azure or AWS, it's your choice. But you have to do certain kind of due diligence for that. What are the cost implications? Okay, so those kind of things happen in the enterprises. So they actually approach organizations like TCS and other organizations to give that kind of options about what are the benefits, what are the approaches that you can actually give to the customer when we decide to move to the cloud. Should we start off with the AWS? Should we start off with the Google? Okay, so that kind of questions customer pose to us. Now it is actually very difficult, because in today's world, all the service providers actually provide almost all the services in computing, in storage, and everything. Everyone has their own pros and cons. So it's not that like a particular service suits every of the customers. At the organization level and the enterprise level, they have certain tie-ups. Okay, so for that purpose, they provide that kind of collaboration with that service provider. Now, then we have to determine the optimal cloud topology. Okay, what are the different ecosystems of applications that they want to migrate to the cloud? That is, let's say, like 5 to 6 months that discovery happens, and then they have to strategize. So they have to prepare a cloud transformation plan. It is not a very easy thing. Okay, now it is an operational application, a live application. Now, if you want to migrate that to the cloud, what are the steps to be followed? Okay, you cannot simply just down the application and move it like for 6 months, and you build that and migrate that to cloud, and then you roll out that to the customers. It is not allowable. So you have to methodically, meticulously plan about what best way you can take to migrate the application gradually into the cloud. I'll cover some of the case studies that we had executed just to give you a more kind of clear picture on that. Okay, then we have to consider the relevant cloud application development abstractions. Like it's not necessary that in the cloud service, like every of the services, the computing or the storage, okay, everything we did not be using. So when we are taking the subscription for a cloud, we have to decide that what are the typical services that the customer actually needs in order to transform that their platform or the application into the cloud. Then we have to formulate the data security and privacy policy, which is very important. Often the enterprises are having big fallouts and myths in this particular area, that they are not kind of taking that into very seriously about the data security and the privacy policies. Because the cloud, every of the cloud has their own kind of security architecture. They have their own kind of mechanism in how to secure the data. Now, it's not necessary that an particular sensitive data can be actually securely hosted in the cloud for a particular cloud service provider. Now they have to take the decision, they have to understand like whether the security architecture actually will be able to protect my data, protect the sensitive data. There is, if there is any possibility about that getting leaked out. Okay, so those things need to be evaluated. So in a lot of cases, we have seen that this kind of analysis, this kind of assessment, it takes not less than a year. Okay, like to get to that mature state. If it's a big organization and if it's having a very big data ecosystem. Okay, sorry. Then comes the critical phase of implementing. So once we have identified the applications that are eligible for the cloud migration, we have identified the services that need to be used, we have identified the security governance architecture, then we start the design and the migration. Obviously, as I said, like it is not a good idea to have a big bang approach. Rather, we have to take some pilot examples, pilot applications, which are, I would say, like what we have experienced is that the less sensitive applications, which are more kind of mission critical applications which are having a direct interface with the users, and you cannot have a downtime for that, do not go for that cloud migration for those kind of applications to be begin with as a pilot. For piloting applications, go to a more less sensitive kind of application, which is not having that much of business impact. Okay, because you never know that what will be the outcome for that. Okay, then you start managing your cloud and the data security through comprehensive tooling. Tooling, when we say, it's basically the services that the cloud provides. So you manage your entire ecosystem. Once the migration is done, then you actually just get rid of your on-premises storage applications and everything. You gradually move to the cloud, and you start managing every of the services to the cloud. Okay, the difficult step here comes is how to educate the users. So that is a kind of big challenge. So there are different ways in which the enterprises have taken to educate the users to adopt to the cloud new services. Once you are in a stable state, I would say stable state, maybe around 1 or 2 years, then you start to optimize and modernize your platform. Obviously, you cannot plan for modernization the very day one. So once you have that kind of steady state, now you think like how to use the more kind of niche services of the cloud, how you can actually build in more kind of data analytics or kind of kind of different computing services that you can add to the platform. So those kind of modernization you start planning at the end stage. So there is no end to that actually. Okay, you can keep on enhancing, you can keep on modernizing your platform to whatever extent is possible. Okay, the ultimate objective is get go completely serverless. So serverless is basically like it's a your entire application ecosystem is at in the cloud. That is your end state. Okay, so you are able to now methodically transform every of your applications to the cloud, and you have totally got rid of any of the on-premises, any applications or any kind of service and those kind of things. Okay, but you all must be knowing that basically, like when we say serverless, though we are not directly using a server, okay, we don't have a physical server, but it's not that the server concept itself has gone away in the cloud. It is absolutely not that. In cloud, we are actually using another person's server. It's basically the service provider is having servers at their end. It is not absolutely that it is totally virtual. Okay. Why it is virtual? Because are not maintaining that. We are not having direct connectivity or direct maintenance of that. But ultimately, a service provider is actually kind of maintaining that. He is getting that service provider to be. But that server architecture is still lying in the cloud, to be very, very precise. Okay. Now, I'll try to focus into more the application migration part. As I mentioned, there are different strategies, okay, different options that an enterprise can take in if you're deciding to migrate a particular application to the cloud, or if there are a lot of host of applications in your enterprise which they want to migrate to the cloud. There are multiple options. For example, like in some cases, in some use cases which have sensitive data, they might need to retain that application in the on-premise only. It is not a good candidate. Like again, I repeat that it's not a very kind of do not go by the myth that migrating everything to the cloud has its own advantage. It is absolutely not true, because there are certain cases in terms of we are experiencing that from our standpoint, from performance perspective, from seamless integration perspective. The on-premises, for example, if I take the example of even mainframe, okay, or even the Teradata, okay, so they have achieved that benchmark of performance over the years. Okay, so in some cases, the cloud services are failing. Okay, what we have seen, if it is not designed properly, if it is not architected properly, even the cloud service, for example, Amazon, if you're designing the EC2 service, if it is not kind of designed properly, planned properly, we have seen that it is failing to process huge amount of data at one go. If you take the example of Hadoop, the big data architecture, okay, there, like the way it has been designed, it is robust enough to handle huge volumes of data. Now, in those cases where it is not proven that the cloud will be able to handle that kind of a data in that with giving that performance out, so client or the customer should not be going into the cloud. They need essentially to retain that application into the on-premise, bearing the cost of the current licensing. Okay, that is an advisable thing to be done. There are cases where sensitive, very high sensitive data are actually maintained, and it is need to be secure. Okay, so for example, like if I take the example of the stock exchange, okay, or even the, I'm not sure whether the railways have migrated that entire application to the cloud, but I think they're still in mainframe. Okay, so still in the legacy world or in the enterprises, there are a lot of applications which are actually still running in the mainframes, still running in the old Teradata kind of applications, where it is proven thing that it is kind of it's a secure thing. Okay, so they have their reliability, they have proven the reliability, and they have proven the performance also. So in those cases, obviously, you have to decide that maybe it's not better to move to the cloud. Okay. Now, in the cloud migration journey, there are certain applications which can be phased out. Those are not kind of getting to any use for the users over the period of time. So, in one way, often what it happens, like if you continue with your application in the on-premise, the legacy application, you continue to grow certain of the unused applications. Like those are not getting used in any way. It's not helpful also for the enterprise. So, but there is a kind of lethargy in the enterprises that they don't retire those applications, they don't decommission those applications. It gets on continually operate, though there are no users. So they end up in bearing the cost for that. So in one way, if you do a huge migration to the cloud, there is an opportunity that you identify those applications which is not used at all, okay, and then you can typically phase out those applications. There is another option of rehosting, which is commonly known as the lift and the shift. Now, uh, when you don't have the transparency about, let's say you have a very complex application involving the front end and the back end, okay, services. Now you don't know that what is the best methodology, the tactics of moving to the cloud. So you do a lift and shift. So you just re-platform, re-host that. Then that particular same architecture you move to the cloud. In this case, typically it is more of a kind of an IaaS kind of usage of the cloud, like infrastructure as a service. Okay, so you were having an on-premise server. Okay, you move that application entirely to the cloud server. That is the easiest way. Okay, it needs minimum kind of integration, minimum kind of changes in the application. It is a very swift migration. So in some cases, like just for the sake of moving to the cloud, just get rid of the on-premises resources, customers do follow this method of lift and shift. Okay, so they don't want to change the application, they don't want to invest into changing the application entirely, because cloud services and applications has their own benefits. Like if you design the applications in the native cloud services, there are typically some performance improvements, there are some optimization improvements are there. So but you have to do a lot of changes in the application for that. So in some cases, we have seen customers do not encourage that. They are quite okay with like kind of just lifting a particular application from the on-premise server and just move that to the cloud server. That is that is all they want basically. Okay, so that's a minimum effort, and often we have also seen that it's basically more easier for us to follow this approach. Replatforming is something like it's a lift, tinker, and shift kind of method. What they say, it involves certain minor optimizations, okay, to the applications, okay, uh, such as like we have software updates, we have some configuration tweaks, okay. Now we can actually use a cloud native service, like for example, the Kubernetes as a service or database as a service. So those kind of inbuilt native services of the cloud, like database as a service, that those kind of methods are followed. I just give you an example about like if you transition on one of your traditional Oracle database, okay, into the cloud-based option like Amazon RDS. This is something that we had done in one of the cases. So that Oracle entire database was moved into the Amazon RDS. RDS is relational data services for Amazon. So there were certain changes in the integrations that had to be done during this migration journey, but it needs time. So often the customers do not have that time to port this application. They are content with the third option, that is the rehosting. So replatform is something more complex, okay, a bit more complex, which applies better for certain of the applications, more like database migrations and like the front end migrations. So those kind of things, those are kind of more suitable for the replatforming option. Repurchase is something a very different thing. Like it comes into play like when an application isn't suitable for the cloud deployment on the existing licensing. For any traditional licensing software, like it doesn't allow you to bring your own license. What typically happens is that like in some cases, native application what you had initially built over the years, that was not portable to the cloud. Like if you migrate that application lift and shift wise to the cloud, it will stop working. So it doesn't provide those integration and options about the about whether it needs to work seamlessly after moving to the cloud. In that case, there is absolutely no option that you have to remigrate or totally rechange your software. One of the examples is that on-premises customer relationship management (CRM) system, you may have defined, you may have built using some different on-premise application or software that you have to migrate to Salesforce. Salesforce is one of the leading CRM like services in the cloud. So that is one option. So this is a very expensive option. Often, like customers maybe like prefer to stick to the on-premise. In this kind of scenario, happens that that particular service application, it doesn't adopt to the cloud. It doesn't. It cannot integrate to the cloud. They don't follow this option. Okay, it's kind of repurchasing. The last option, what we have seen is a refactor, re-architect. This is something of the kind of a entirely building through scratch. Okay, now this is like you have to totally decide re-architect. Like you are having an on-premise application architecture, so you have to totally decide about if I need to move to the cloud, how best we can do the assessment. Okay, how each of the services we have to kind of redesign and rebuild in the using the cloud services. I'll cover a case study where I will show that how we have used this kind of option about re-architecting. This is one of the cleanest approach, okay, where you totally kind of understand the existing application, what are the logics, how it has been designed, okay, and you rebuild the entire thing by getting that knowledge out of that application. So this is something, but you build the things into cloud natives using cloud native services. That is the difference over here, okay. So it is the most kind of tradition. I mean, the most robust, I would say, the robust method to transform or migrate an application to the cloud. But often this gets very difficult. Okay, it is not that easy. We have seen for one of the case studies. I will explain that later. Because understanding a legacy application, it's very difficult. Okay, so the thing is that like it takes a lot of time for any depends on the quantum of the applications, the number of kind of complexity, the function points. So that adds to the complexity and the time for the migration. So what is the conclusion about this application migration strategies? Like we have gone across the different options. Like we can be repurchased, we can refactor that, we can rehost that. It can be totally decommissioned also. You can retain some of the applications. So a lot of options customer has to decide. Okay, depending on what is the complexity, what is the current platform of the application. Now, what's the conclusion? Like the customer should be confused about like doesn't have a guideline about if he wants to move to the cloud. Like for the applications, what is the best approach? So as I said, there is nothing as a universal solution for everyone. Okay, it's not like one size doesn't fit all. So enterprises have to look methodically and in minute detail about what is the best successful option about migrating a particular application into the cloud. Okay, they can optimize their approach by emulating like effective strategies, adapting to their unique requirements. But it is not proven. It is not that they will get the success. They will get the benefits of the cloud in a particular migration. So it's an evolving journey. Okay, they have to take the time to understand the new platform. It is something new to them. We have seen that they are nervous. I mean, the customers after implementation, they are nervous that whether I'm going to incur more cost, whether it's going to hit the performance of the application. It used to be very, very properly running. Now in the cloud, suddenly some kind of problems started happening. There can be data losses also. We have seen that in accidental cases, there had been data losses. In some cases, the cloud could restore that, but in some cases, it was a permanent loss. So in one way, those kind of things are not that easy as said. Like the cloud is totally secured. You can rule out every possibility of any data loss. So in the real world, we have seen that there are scenarios where the data loss can also happen. Okay, so that makes the customer nervous actually. Like whether to rely upon the cloud, whether from data security perspective or from performance perspective, whether it's the best suited thing. So those all things actually matter. Okay, so again, I said that this is not a single solution for everyone. Maybe for a particular customer, returning to the on-premise application is even better for him. Okay, it's not worth transforming to the cloud. Now, the strategic, like the strategic to prioritize the migration projects based on the business needs. Business need to have the backing also. It's not that like it's any migration to cloud. This is one interesting thing. Like none of the cloud migration journeys are actually kind of encouraged and backed by the business, because business what they need is my operations should work fine. I should be able to access this data. I should be able to access the application when I need. If you consider your own example, individual example, like in your mobile phone, when your OS is getting upgraded, are you really bothered about the OS upgrade? Because it's totally a technical thing. You don't know the benefit that the phone will provide to you when you upgrade the OS. Okay, but you go for it, often knowingly, often unknowingly. The thing is that like often we take the decision that we don't upgrade the OS because some of us has faced the repercussions that after upgrading the OS, my performance of the phone has degraded. So in that case, it gets difficult for us to decide whether to apply for the upgrade. The same thing happens for the enterprises also, that after the implementation happens, they start facing a lot of challenges. Okay, so they start questioning. So that is the reason why none of these programs actually we have seen from our experience that the business has that much backing to this kind of migrations. They always want to see that what are the benefits that you will give. Are we going to really take any benefit when we migrate to the cloud? Are we going to have a beautiful screen? Are we going to have a beautiful user interface? Are we going to get the data sooner than we are getting right now? All these are the questions that the business asks to the IT of the enterprises. That whether you are able to provide these many benefits to us. Otherwise, like business is not going to fund this kind of programs. That is the reason I repeat, like in the initial stage, I said that executive backing is very important for a migration. So unless the leadership, the organization has that kind of support, because you don't actually cannot visualize, cannot prove the actual benefits of the cloud migration to a business unless it is implemented, it is evolved through the period of let's say 5 to 6 months. Then only probably you can start showing some kind of benefit, not before that. Okay, so that gets very difficult and tricky part for the organizations to decide. Now they have to invest for training the staff and master like new tools and technology. That is a big challenge for them also. So this is some kind of summarized conclusion about like the application migration when they plan to do. So what are the decisions that they need to take and what are the rationales? In what way they can actually decide their mind that okay, we should go for the migrations. This is more of a cloud computing services, which I think you have must be aware of this thing. Mostly the cloud has like three kind of like services that they provide. One is the infrastructure as a service, like where they just provide the hardware, the infrastructure. You can port your application over into that their infrastructure. Their platform as a service, it is their integrated kind of environment that they provide. You did not bother about that environment, integrations, everything that they provide. And even if you want more, that you don't want to involve even in coding or and in designing the applications, like you want to use as ready-made as a software as a service. So there also they have plenty of options, like when they provide this kind of software as a service model. Now, obviously, as you understand, like there's a cost variance between these three. The less you take, the less you pay. The more you take, the more you pay. So software as a service is something you are having extensive kind of usage of the cloud. Okay, you are having the hardware, you are having the platform, you are having the software also. So obviously, it is quite implied that software as a service is something where you'll be paying the most. Okay, the list means basically as infrastructure as a service. So it depends on enterprise to enterprise in what option they subscribe for the cloud. In some cases, they are going for even multi-cloud environments. Like often they have evaluated that particular service provider, it's kind of incurring more cost. Okay, in particular service, so they have kind of moved to a different cloud. So it's not that they are maintaining only one cloud. Maybe they are maintaining some of the applications in one cloud, some of the applications in other cloud. This is another way enterprises are kind of evaluating like which cloud is better for them. Okay, so this kind of things actually are happening in the real world. Now, this is one interesting thing, the data security. Okay, often we have seen in the cloud, like data breaches and unauthorized access happen. Not only the clouds, but in the real world also, in the traditional architecture also. We have seen the data breaches and unauthorized access happen. Insider threats is one of the predominant thing. Data loss is also happening. Okay, vulnerabilities in the shared infrastructure. Like in the cloud, what happens is the infrastructure is actually shared. So it's not that like cloud is providing, let's say, organization X. Now, organization X has subscribed for the AWS cloud, and AWS has and given him one particular EC2 server. Now it is on a dedicated server, mind it, like it is a shared server. So it's not necessary that that only organization X is using that. Maybe organization Y is also using that. So the entire thing is a virtual. Okay, so the security is kind of designed that whoever are the users for organization X will be able to access the data points and the services belonging or tagged to the organization X. Now, but physically the server is the same. You cannot see the server, but this physically the server is the same. Now, the question comes that there can be possibilities that there can be exchanges of information, or there can be vulnerabilities in the architecture where some kind of information can get leaked to the organization Y. So that kind of risk also stay, and that kind of risk do happen. Okay, data breaches, data losses also can happen. Insider threats is another big thing. Okay, where the data loss can happen. Now the question is that the customers ask is that if I lost the data, what are the possibilities that cloud will actually restore me back the data? How much is the possibility? So the cloud service providers obviously they proclaim that okay, we can restore the data in all means, but in some cases we have seen that there may be potential data loss for the as a permanent measure. Now, these are some of the best practices what the cloud actually provides you, in which way that you can protect your data, like you can secure data. Encryption, data masking is some of the beautiful things that they have actually provided to us. It is a very strong method of protecting the data. Data masking is one of them. Identity access management, this term you'll come across if you have a deeper understanding and deeper just try to have deeper knowledge about the cloud. In every of the cloud, this identity and access management plays a very critical role. In one way, like in one particular data or application or service, like a particular user, how you are actually going to control and regulate the access for the user. That entire thing that is controlled by this identity and access management. So identity means that you are a particular user of the cloud, the service. Now, how many services are you going to use? In what way? Are you going to have a read access? Are you also going to have a write access? Or you're also going to have an execute access? These are the three main type of access that an user can get into a particular service. Okay, so that entire thing gets administered or controlled by the system administrators. In the traditional world, we used to have the system administrators. Over here in the cloud, we have the cloud administrators who control the security part of it, like the entire access control. Okay, continuous monitoring and the threat detection. So it is very essential, needless to say, that even though we have dumped our entire ecosystem and application to the cloud service provider, but are we safe? That brings the question that are we really safe? So the thing is that your application is your own rights, your onus. Like in different models, the cloud service provider doesn't take the ownership of maintaining your data or maintaining your the services. Okay. Now it depends on you how you're paying for the subscription. So in the different models, if you see, like ultimately the best owners of your application should be with you. So it is on your side that you should be continuously monitoring that how my operation is going on, what are the performance that is if the cloud is providing to us, and is there any threat or any kind of potential threat. You should take the immediate measures about how to mitigate that. In some cases, you have to take the help of the cloud service providers also. Okay, secure configuration and patch management. This is something fundamental for the safeguarding of the cloud infrastructure. Disaster recovery and the backup planning. This is what used to be meticulously planned in the on-premise architecture. Disaster recovery is something that when something disaster happens, let's say one of the application server crashes. So what is your disaster recovery plan? And what is your backup plan? Are we going to totally kind of leave that application to its perishable state, or you're going to have some backup planning? So those kind of things also happen in the cloud environment. Okay, so you have to do that kind of disaster recovery and the backup planning. So for mission critical applications, obviously, you have to plan for those kind of parallel kind of computing clusters of computing services, where if one particular cluster goes down, automatically that other cluster picks up. Because in the real world, the amount of data, the amount of the traffics of data that is actually encountered it's pretty huge. Okay, so obviously the configuration of the servers or the configuration of the services that need to meticulously planned about to cater to the performance, cater to the disaster recovery also. Like if something goes wrong, then immediately the backup instance should be start playing into action. Now, this is more of a kind of a like till now I had been giving some kind of insights about how the enterprises have taken up the journey, what are the best practices, what are the challenges faced. So here is some real life example. Okay, what we had kind of did one of the migrations. So this was a life science customer, US based. So they had one of the legacy Teradata data warehouse, like data warehouse that like they had been built for almost 10 years. So this data warehouse is entirely existing and residing in the Teradata. Integration services were using Informatica as an ETL tool. Okay, these are the main, and the entire Teradata was hosted on Unix servers. So, like, it was more of a kind of having almost, I would say, around 20 to 30 terabytes of data. Okay, and applications in counts like almost more than 500 to 600 of the ETL transformations, the integration routines were there. It was a very complex kind of a data warehouse built over the ages, in obviously in Teradata. It was highly performant. There was no concern about the performance part of it. But the problem that they were facing is that over the time, it has grown huge. Now, they were lacking the knowledge about maintaining that also. A lot of the applications, lot of business rules have been incorporated into the ETLs. No one was aware of. Okay, that was one of the big challenge. Like for any new kind of change, it was very difficult to get the proper people behind that who can actually do the changes. That was one of the rationale. The biggest rationale was the licensing cost of the Teradata. So the physical servers that they have procured and the Teradata that they have procured, licensing was soon going to expire, and it was a huge cost in the renewal of the license. And overall, as an organization, they had embarked upon the journey that they will be migrating to the Azure cloud. So this was one of the programs that they had undertaken to have that entire data warehouse migrated to the Azure services. Now, I had discussed a few minutes back about the options that they can take to migrate a particular application. There can be rehost, it can be replatformed. So this is one example that we did some initial discovery analysis, and we came to a certain point that it cannot be simply lift and shift. Like Teradata cannot be lifted and shifted to the Azure service, like Azure platform, Azure servers. Okay, it is not worth it because anyway Teradata has to move away. Teradata licensing is going to expire. They are not going to continue using Teradata. So the only option that was with us was re-architecting or redesigning the entire thing. So basically, we started off the journey in understanding like what are the discrete data sources that were feeding the data into the data warehouse. We identified there were multiple different sources. CRM system was there, Oracle system was there, SAP was there, even some AWS Redshift database was also there. Okay. From integration perspective, the ETLs that they had been using, it was predominantly Informatica. In some cases, they had used Talent, that was an ETL tool. So they used to push the data into the data warehouse. The main complexity that was there was the transformation of the business rules that they used and applied over the data to convert the data into the usable format for reporting. Entire logic was embedded into the Teradata. Okay, there are some kind of scripts like BTEC scripts in Teradata. So those kind of things are actually entirely embedded. There were thousands of such scripts built over the time. That was the biggest challenge for us to understand them and re-architect that. So we did some strategies about how best to address that. Fortunately, what we saw that some part of the data was already kind of ingested into the Azure cloud, which was already in a ready state, in some way or the other. So we can that was there in the Azure Synapse basically. Okay. So we can actually borrow some part of the data from there, and in some cases we have to understand the existing ETL rules, okay, and then we have to translate and write everything newly into Azure. Now, when we rebuild the thing into Azure, the main services that we use was basically Databricks. You must, if you must have heard about the Azure Databricks. That is a very powerful tool about like converting and translating the data in different ways. Uh, it is the primary conversion was done using scripts and using PySpark SQL. You must be getting familiar with this thing. Python is one of the leading languages right now, so it is used extensively for those kind of transformations. So just imagine the amount of work that was put in to understand the BitX scripts of Teradata. Entire business rules, they have to be redesigned because the way Teradata has a typical architecture of getting it like transforming the data. But in Azure, what it's a different data modeling altogether. There we have a concept of data lake. Okay, so it's not that like we can replicate each and every of the Teradata tables into Azure. So it's basically a fresh journey, a fresh open mind that was needed, okay, and a complete redesign of the architecture. So in the data lake, we have maintained like raw layer, we have foundation layer, we have enriched layer, and finally we have the curated layer. So it's the data journey starts from the raw layer when we get ingested into the data lake. We term it the ADLS, the ADLS Gen 2. Okay, then we have the foundation layer where we kind of cleanse the data, apply some kind of DQ rule, data quality rules. Then we have enrich layer where we enrich the data with certain attributes, okay, with some validations. And finally, the curated layer. This is a very standard uh, design of a data lake architecture. Okay, in data lake, you dump all the data. So curated data is basically that particular layer of the presentation of the data where it is used for the presentation or the final reporting purpose. Okay. On the bottom side, what you're seeing is the orchestration part of it. Like, what are the services that you are using for orchestrating that? Okay, orchestrating or like the different workflows that we are creating. Okay, different kind of ETL programs that we are creating. We use the Azure Data Factory over here. I'm just mentioning the few service names just for the sake of understanding because most of you may be knowing this kind of service names if you have already studied Azure Cloud. Okay, these are very powerful services that are provided by Azure. We have Synapse service, we have data catalog, we have Azure Monitor, okay, we have Azure Log Analytics. DevOps is obviously something like which we use for the continuous integration, continuous deployment. And at the end of the story, what we build the data into the data lake, in the data brick, basically we build some delta lake in the data bricks, which is the final curated model of the data. So that data was used to render into the Power BI reporting, like the reporting was done using Power BI. So this is just a kind of clean picture about how like that this is one of the example only. It is not that this is the best example or this is the only way that we can migrate an entire data warehouse, but this is some option that we have tried out. Okay, and it went on as a very big success. And basically, we were managed to rationalize most of the applications because in the legacy world, what we see that there were almost more than 50 to 60 applications and even data sources that were not used at all. So in the journey, we had did rationalize and decommission those things. And the way the new data lake was designed, it was highly performant also. Okay, so the Databricks, the coding that was done in the Databricks, okay, so those were also very highly performant, and in the clusters or the configurations that we use for the infrastructure in the cloud, that was also very highly performant. So obviously, it was able to process a huge amount of data in one shot. So this is one of the use cases. The second case that I just want to quickly show you is that this is something of an AWS implementation. It's Amazon Cloud. So here also it's a kind of a data lake migration. We built a centralized data lake on AWS. The data source was lying on the SQL Server DB. Okay, there was some streaming data also, as I mentioned. Some live data was streamed. So NiFi was used for that NiFi service. Activity is another tool that was used. Okay, and the main transformations and the conversions was done using PySpark over here. And the storage for the AWS, this is just the names are different. In Azure, we have the ADLS, Azure Data Lake Service, or the blobs. Here we have the EC2, the S3 buckets. You must be aware of that. So the S3 buckets are here we have designed the data lake sort of it. Here also we have the raw, the staging, and the AWS layer. Okay, the curated layer over here. And these are the different separate EMR for each group, like the different the servers that were running on the backend that we procured the EMR for the AWS side. The AWS Glue Catalog, this is something of an ETL tool. So initially, that was ETL was there using data stage. So here we have used the Glue Catalog, the AWS Glue, as an ETL tool over here to transform the data. So if you did not understand the entire architecture, the reason I am showing you this is that uh, these are typically the cloud services that are used for. You need to have a clean understanding about what are the computing resources or computing services that AWS provides or even Azure provides. Okay, where it is exactly getting used. So you may be studying in your curriculum about the individual services. Okay, But if you look at this architecture, you'll get a better understanding about in the real world for a particular application how the services come into play. Where should I best fit my service? For example, S3, you must have heard theoretically, like what is S3? You see the actual usage of S3 over here. Like you want to store the data over here. Once you ingest the data from a particular source, you are actually like putting the data and recording the data onto different layers within the S3. You can design in that way. So you now know that this is my use case. I can, if this is a requirement for any other case, I can safely use the S3 over here. So that is the purpose I just showed you two architectures over here. How the data flow architecture looks like. It is simply a logical architecture, like just to show you like how the AWS or the Azure services come into play. Okay. Now, having said all of these things, like these, I was talking entirely about the enterprises, the organizations that we are working for as an TCS or any other organization. Now, during the advent of this cloud transformation as a service industry, because TCS is obviously service industry, we are providing our service and consultancy to the other big organizations. So in our side, due to this advancement or advent in this cloud transformation, so how are organizations like TCS or IBM or Accenture, so how are these organizations getting coped up into? Like, how are they transforming themselves? Because the journey cannot happen on a one-to-one basis. Like only the customers, enterprises cannot transform themselves because we have to provide the service. So as a service organization, we are also kind of transforming. So, and it is a big challenge. Okay, so it's a rapid development, as I said, like over the last 10 years and 5 years. So there had been huge, remarkable amount of change and transformation. So how how are TCS like organizations kind of coping up to that? So some of the options that we are taking is like redesign the organization structure overall. Like we are creating some kind of center of excellences. Like obviously, all people cannot work for all of the things. Okay, there should be some kind of center of excellences where few people who are trained in the executions in like cloud services like Azure, AWS, GCP, they should form a core team and the center of excellences who should actually put the consultancy, do that kind of guidance to the remaining team, do that kind of pre-sales, marketing kind of approaches to the customer whenever the customer approaches with a certain requirement for cloud transformations. Entire organization cannot jump in. Few people who have that core expertise, core knowledge, they only should be able to present that what TCS can provide to their customer. Okay, so that's the reason why different center of excellences have been built within the organization who are actively working to enhance their knowledge into the cloud services, enhance like the consultancy practices within the different projects, the different accounts, the relationships. Okay, that is their role. Emphasize on the pre-sales to show the cloud capabilities. TCS has an organization has kind of delivered a lot of different cloud migration journeys, interesting examples using different type of cloud platforms as a part of pre-sales to the different new customers, new organizations, new enterprises. We try to showcase the cloud capabilities also, what TCS has already provided to the other customers. Maybe one customer can find the correlation with what TCS has delivered for one another prior customer. We can readily kind of take that knowledge what from what we had implemented in one customer and apply that to the for the new customer. That is also what happens often. Competency building is another key part, like a lot of online competency building certifications, external certifications. These are put mandatory for the associates who are trying to work in this data area. And as an organization, it's a huge organization, so it's building some proprietary tools and accelerators also, how to facilitate the cloud transformations, like some kind of accelerators. Okay, like these are kind of in-house tools. For example, like if you need to write like transform some kind of informatica mappings into some Python scripts, so there are a certain kind of in-house tools which we use to kind of convert that easily. It's not an absolute 100% is kind of converted, but we have to do some kind of manual transformations. But it's an accelerator. The basic thing can be translated. So those kind, like it's focusing on to building those kind of proprietary tools so that those kind of accelerator kind of things happen. Now, what is the future for this? Okay, like we are moving at a kind of rapid pace in this cloud transformations. So, as I said, like, one of the paradigm of this cloud environment is like we are having multi-cloud architecture. Like most of the organizations are still not kind of convinced, still not having that confidence in like whether they are really able to save the cost, have the cost optimization. In terms of data loss also, they are kind of quite skeptical. So they are opting for multi-cloud. So for certain of the services, like for example, for analytics services, like data analytics and data science, for that, Google has created a huge amount of kind of services for that. Okay, like different kind of services there. Like maybe AWS is expert in terms of storage. It has a minimum cost. So that need to be evaluated. So in one way, the enterprises are kind of looking into architecture where they want to store the data into, let's say, AWS. From storage perspective, they want to store the data in AWS. From computational perspective, they are relying upon Azure. Okay. From the data presentation or the analytics purposes, they are relying upon GCP, Google Cloud. So that kind of architecture also is nowadays kind of picking up the demand, and we are actually having to follow that option, like what are the data exchange policies, because in that way, when multiple kind of clouds are used, so the data security governance, that becomes very difficult. Okay, so those, but these are the real scenarios that customer are following multi-cloud. In some cases they are following hybrid cloud, like some in the private, some in the public cloud. Those kind of architecture also they are following. So in one way, like those kind of evaluations also we have to do, like whether they it is suitable to have like such many clouds in the ecosystem. It's obviously very difficult. Okay, now, as I said, like cost is one of the biggest factor behind the enterprise to decide whether to go for an cloud transformations, because it is not known to them. It's ever increasing, because if you invest on an on-premise server, okay, in the previous days, you knew that you had a fixed cost. Now in the cloud environment, there is no fixed cost. There are two parts of the cost. One is the capex cost, which is the initial subscription that you procure certain of the servers and those kind of things. The operational cost is what actually is, it's a very tricky thing that the cloud service providers has actually put. So it depends. Just to give you a very simple example, like you have a server, you have a service. Now there are certain services that are not, it doesn't have any cost in the, as in if you procure that, it comes as a part of your own subscription. Okay, the cost actually is actually incurred the more you use. Okay, the number of times and iterations you're using that service, it will incur the cost. So in that way, like it is very difficult for an enterprise customer to previously decide like what will be the OpEx cost. So what they're encountering is that like they have that understanding that I will have a finite cost when I move to the cloud. But the thing is that like once they have moved to the cloud, the capex cost is remaining the same. Okay, but the challenge they are facing is at the OpEx cost, the operational cost. So basically, like it's like it is too much of a cost for them, because they're not able to control the cost. Okay, so that is the challenge they are facing over here. Now the thing is that like there's a concept like FinOps that is coming up. So what the cloud service providers are actually providing them is like initially during the initial phases of the cloud migrations, like the cloud service providers did not have any kind of tools by which they can actually measure the different, they can actually give the transparency to their customers that okay, this is my actual operational cost. So now this FinOps is coming into picture where enterprises are actually asking that okay, if I have 10 applications, tell me that application 1, 2 and 3, how much they are actually having the OpEx cost. Okay, then like for all the applications they are demanding that tell me that how much is the operational cost. Now they are actually kind of evaluating that which are the applications that are actually incurring too much of an operational cost, and they are coming down to the application level. Whoever is the owners of their application, they are trying to hit those application owners that why is the operational cost getting too high for those kind of applications. So that kind of analysis is getting done. So they're tracking that cost in that way. Okay, so that is one thing that is very much new and that is picking up the demand as the cost is very important. Enterprise browser, this is something interesting. I just came up a few days back. Like I was also not aware of this. Like it is a very common understanding that as we have moved to the cloud, if you have seen, most of the services that we are using for the cloud, these are all browser based. Okay, you can use either Chrome or Edge, whatever. But actual entire thing is getting driven by the browser. When the work started for the cloud, no one actually believed that okay, like we just assume that the normal browsers that we use, like Chrome or IE, these are sufficient enough. These are good enough for using the cloud services. But often it is seen that these normal browsers are not secured enough. They doesn't have that kind of robust infrastructure, robust architecture to protect, to safeguard the data exchanges that happen through the browsers. Okay, so the thing is that like we unknowingly use the browsers, even in our organizations also, we just use Chrome and all those things. But often there may be possibilities that these browsers are not that much suitably architected for handling the super secure data for the cloud. So nowadays, recently, it is a very recent trend that some of the there is some trend where some enterprise browsers are getting built, which will be typically used only for the enterprise operations, whichever is are involving the cloud applications. You can use normal browser for your own use, personal use, but it is a thing that you have to use those enterprise browsers. This is also picking up the demand that these are typically built keeping in mind the security that cloud demands. Okay, so it is the most efficient data management and seamless integration with the entire business process. Okay, so this is something, this obviously there are a lot of things going on. The future is quite huge. It's a vast area. No one knows like where it will end up. Also, like on the other side, there is an AI, like the huge world of AI, Gen AI that is coming up. So no one knows like where it will actually end up. It will never end basically, but definitely it is true that cloud is one of the journeys that eventually all the enterprises would need to take. It's not that everything has to move to the cloud, as I said, but majority of the new applications, whatever new applications are getting designed, everything is getting designed keeping in mind the cloud services only. At least whatever has been already been done, so those things are already done, so there is hardly any options to kind of do anything other than migration. But for the new things that are getting built, obviously customers are kind of following that. They probably it's better idea to move to the cloud keeping in mind the future context of the same. Okay, so having said that, I come to a kind of a conclusion. Okay, this is an ending slide. Okay, so it's obviously we all know that difficult things, while like obviously we have to do the difficult things while they're easy. So it's more of a kind of context like from any kind of cloud migration. So for any kind of such journey, so we have to do the difficult things while they're easy and do the great things while they're small. Okay, and obviously we all know journey of 1,000 miles must begin with a single step. So that's the end of it. Okay. Uh, so I believe, just a second. Yeah. So hopefully, I think I was able to bring some context to the topic, and I believe, though it was a bit of a kind of theoretical in some cases, but I believe I was able to portray at least some of the real experiences where the enterprises are going, where organizations like TCS is going, how much of the cloud we are using, what are the challenges. So in a nutshell, I think I was able to kind of provide you that kind of idea. I'm welcome to any kind of interactions or questions or any doubts if you're having from any of you.
The floor is open for any questions or doubts you may have. Sir is up for an interactive session. Please feel free to unmute yourself or type your questions in the chat.
So it's just an open question for me. Like I see like a lot of students have joined. So any of you have already started kind of knowing some bit more of any of the cloud services like maybe Azure or AWS, whoever. Like, have you started learning the services, taking some more interest into any of the clouds? Are you facing any challenges in understanding like what is the what is the kind of services they are providing? And are you any of you have were able to relate to whatever I was showing in the slides? any other terms like the services I mentioned or the text that I mentioned. So I hope like you must be having some cloud context in your curriculum also, but were you able to relate some, at least to some extent, with what I was explaining, or it was totally kind of a new thing to you? Okay. Okay. I think it's from Shania Balki. Yep, this is obviously an obvious question that as a student with limited experience in cloud computing, like what are some of the entry level certifications or training programs? So, like first of all, like there are different cloud service providers, like kind of certifications or architect level certifications. To start with, you will see that if you go to the certifications for any, you can go to the portal of the Azure. Just for example, I don't recollect the exact certification course name, but you will find that there are some kind of overview kind of certifications, like which you can take up as a process perspective, just to get an overall understanding. uh, I would also suggest that before you go for any kind of certifications, okay, because certifications actually is necessary from the professional perspective. Like when you join a particular organization, then obviously you'll be asked to do some certifications. But from your academic perspective, I would suggest that you better first start to get a more understanding of that. So you will find very good courses in like portals like Udemy. Okay, there are certain other portals also where you will find courses where it provides for the cloud services. So I'd recommend that you can go to Udemy. Okay, you can browse through certain of the Azure or the GCP or the AWS courses. Try to get that understanding first. You will find yourself more confident, and then you can plan for any kind of certifications for any of the clouds. But obviously, you have to take step by step. At very first, it should be the process overview, then the developer certifications, and finally, over the experience once you gather, you will need to take the architect level certifications. I hope I answered that. Any other friends? Okay, that's from Ashutosh Singh. How do cloud computing technologies intersect with other emerging technologies such as artificial intelligence, Internet of Things, or blockchain, and what opportunities do these intersections present for students? See, as I said, like uh, cloud is a kind of a platform. Okay, cloud is not AI, cloud is not Internet of Things, and cloud is neither blockchain. So these are all different things. So cloud is a platform. Now, the interesting thing about cloud is that it provides multiple options. Predominantly, it provides options of computing, it provides options of storage. And obviously, there are other different services which you can use for having further specialized kind of computing and processing of the data. That is what it provides. And from visualization's perspective, also, cloud provides certain services. Now, if you're interested in Gen AI, okay, what I would actually suggest is that Gen AI or AI, you need not know cloud, okay, cloud services at all if you want to learn Gen AI or AI for purpose, machine level machine language, okay, even Internet of Things. So those are different subjects altogether. But the interesting thing is that uh, if you have the understanding of those kind of things, you will, and also have some understanding on the cloud services. So you will have that portability that if you're asked to integrate a particular Gen AI or Internet of Things services within the cloud, okay, so you can easily find out that if you want to use that particular Internet of Things application, okay, inside the cloud, what is the options, what are the steps that you should follow? You can use one of the GenAI applications, okay. Now, you can write some code into that. Now, how to port that code into the cloud? So obviously, like, as I said, like, if you're expert in the Internet of Things, or if you're expert in the AI ML, that is a different kind of expertise altogether. That is a different competency altogether. You will have plenty of opportunities. You need not necessarily learn or know any cloud in detail for that purpose. What you will be focused is that if you're really interested in knowing the GenAI, you should be focused in understanding the concepts of GenAI, how to use that, how to program for that, how to make the best use of the data. The additional knowledge of the cloud will actually help you in porting or building a particular GenAI solution inside the cloud. It will help you to integrate and get the data which is needed by the Gen AI application. Okay, how to integrate the data from the different sources. For example, like if you are having one particular data set of in lying in Azure, let's say Azure Blob, and you are having a Gen AI applications which will read the data. So you know that, okay, it is a simple way how to integrate and how to pull the data from that particular blob storage. Okay, from that perspective, the cloud knowledge is required. You did not have extensive knowledge in the cloud. Okay, so that is the thing. So you need to decide in which area in which you should be focusing and building the expertise. So that is the thing. So it's all intersects. Like as I said, like all of these emerging kind of technologies are all kind of hosted on cloud. Okay, so you need to know that integrations, that is what is mostly needed, nothing else. But your focus should be on understanding the data model, the Gen AI concepts, okay, or even the Internet of Things. So those all things are should be your focus. Okay, hope that explains. Okay, okay, this is from Shayan there. What about the data privacy concerns when it comes to allowing some cloud provider to store critical data instead of hosting my own service on an on-premise? Are these measures in place if, for example, some data breach occurs? Yeah, as I already explained, like this security part of the data is very critical. It's actually a kind of a controversial discussion that emerged, like whether or not hosting the data, the sensitive data in cloud is really worth it. Is it really kind of secure? So the real example is that uh, if you take the some of the very I would say some of the most categorically the most sensitive data in the whole world. Okay, for example, the stock exchanges data, or even the security, the country's secure data. Okay, which is used for the international security, or even the administration part security. These all are very sensitive data, and I can promise you, like these most of this data are still residing on on-premise servers or on-premise applications. It is probably never going to be put into the cloud, because cloud service can never guarantee, okay, that this information cannot get leaked. Obviously, like this things doesn't happen, there are too much of a security, but as you're putting that information into the internet, okay, obviously there are certain vulnerability. So that question still remains, that yeah, whether the data is perfectly secured or not, still a little amount of question remains. It's not that like the data that is residing on premise that has never got hacked. That is also possible. But the cloud is that like it's not in your control. The onus of the maintaining the data is on the cloud service provider. So that is something is it's very kind of a dicey thing. Okay, so there's an absolute like yes or no, there is no answer to that. So there are risks, there are vulnerabilities, but obviously nowadays it has advanced too much, like the security in the cloud is quite robust, and it can guarantee that your data will not get lost. Hope that answers. What else?
Please ask if you have any more doubts. Thank you.
So overall, like I would expect like how was the interaction? How was the session? Like, did you make at least some part of it, if not all? Was I able to kind of communicate like what was the topic, at least from your perspective. You all must be already knowing a lot of things as an new age students. Uh, you all must be knowing something which we even haven't encountered. But uh, overall, from an industry kind of experience, like how did you like the session? Like, was it contextual to you, or it doesn't seem that interesting? Any one of you? Yep. Thank you.
Thank you, sir. I think it was a very candid session, and thank you for explaining it in so simple terms. The working behind the cloud and learning about the case study was really interesting. We learned some things about the industry and the workings before entering the industry. And the main thing is that all this information, this helps us to provoke thoughts and be more curious about these technologies. So I think there are no more doubts. uh, Please, if any, then you can type in the chat box or unmute yourself. If not, then we can conclude our session. Thank you.
Okay. Thank you all. Then we can sign off probably.
Thank you, sir.
Yep. Thank you
uh,
very much.
we will conclude our session for the first half. Please fill in the attendance and feedback form that is provided in your chat box and join in the second half sharp at 3 o'clock. Thank you.
Okay. Thank you.
Thank you, sir.